All right, let's look at another problem. 4 to the power 2x minus 3 equals 1/4 to the power x plus 1. Okay, remember whenever we solve any exponential equation, we have to make them have the same base. All right, let's do that. Do whatever we can to make them have the same base. All right. So here we already have 4. The base here is 4, but the base here is 1/4. Well, it might be difficult to make 4 to become 1/4, but we can easily make 1/4 to become 4 by making it have exponential negative exponent 1. So let's keep the left side. Then we can change 1/4 to 4 to the power 1. Okay, remember whenever we have a negative exponent, we usually put it under 1 to become 1/4. So kind of going backward. But then we still bring down this x plus 1. Okay, and because we have two terms, we still keep this left side. We're not doing anything with it yet. We're going to distribute these two. But there are two terms here. We multiply it. Negative 1 times x is negative 1x. Then negative 1 times 1 is negative 1. Okay, so now we have the same base, 4. Once the bases are the same, we can set the exponent equal to each other and solve for x. So 2x minus 3 will be equal to negative x minus 1. We can add 3 to both sides. This becomes 0. So 2x is equal to negative x plus 2. So we can add positive x to both sides. Positive 1x, so we have 3x plus negative x plus positive becomes 0 plus 2. So then divide both sides by 3, and then we get x equals 2 over 3. Another way we could do this is, let's go back, just for the sake of, sometimes you have numbers here that are not the same. You can, like 2 can go into here. We can find smaller number. Okay, so it can be 4 is 2 times 2. So if we multiply 2 twice, 2 to the power 2 will be 4. So we can have that and still keep the exponent 2x minus 3. But then we have to change both of them. So it's going to be 4. I'm sorry, I should write 2 again. So 4 is 2 to the power 2. But then it's going to be negative 2 because this is negative. Hold on, this is going back here. This is negative 1, so it's going to be negative 2. And of course, we still have this x plus 1. This x plus 1. So we are 2. So now we're going to distribute this and get 4x. 2 times that is negative 6. Equals then 2. And negative 2 is negative 2x and negative 2. Okay, negative 2 times 1. Okay, so just sometimes it's necessary to use smaller base. Okay, when necessary. But just so you see that we're going to get the same answer. So the 2 is the same base. So 4x minus 6. Going to be negative 2x minus 2. So if we add 2x to both sides, we add 2x to both sides, so that will give us 6x minus 6 plus that 0 minus 2. So if we add 6 to both sides, 6x will be 4. So x will be divide 4 by 6. We divide 4 by 6, and we can simplify more. Dividing by 2, we still get 2 over 3. Okay, so that's the same thing. All right. Here's another problem. Now, if you look at this, it looks a little complicated because we are solving for x and it has fractional exponents. In this type, we want to use a substitution, which we are going to use at a point in calculus. So it's good to kind of have you introduced to that, okay? So let's look at how you solve that. So since we have x to the power 2/3 and 1/3, yes, they are related, so we can let x 1/3 be any variable. So that way we can use that variable to solve. So let's say let n equals x to the 1/3, since 1/3 is smaller. Okay, since it's smaller. So we can substitute n for the 1/3 in this equation now. So if n is 1/3, of course this one is actually x 1/3 squared. Okay, you can rewrite that, c squared minus x 1/3 minus 6 plus. Okay, so then you see clearly what we are substituting. So if we substitute n, it's gonna be n squared minus n minus 6. Okay, this gives us a simple quadratic equation to factor, to solve. Okay, so if we factor that, if we factor this, so n negative 3 times 2 will give negative 6, and negative 3 plus 2 will give negative 1, and so negative 1, the coefficient of n here. So it's minus 3 plus 2. Okay, so if we solve it, then either n minus 3 is equal to 0, or n plus 2 is equal to 0. So n is equal to 3, or n is equal to negative 2. And we have to check for we need to check for extraneous solutions. So let's go back. Since our n, remember we said n is x to the power 1/3, so we're going to replace it in this equation. So if n, write back n. Okay, so we're going to substitute back n here for x, because that's our original. So it's 1/3 equals 3. So to solve for x, we can, even if you change this to the cube root, it's the same thing. So if we cube both sides, so take the cube of both sides, then we cross out 3. So x is going to be 3 times 3 times 3, which is 27. Repeat test is good. So, but if we do x to the power 3 here, x to the power 1/3, we replace it in this part. Okay, so I then do the same thing, take the cube root of, so x is going to be negative 2 times 2, 4, is going to be negative 8. Okay, but then this is negative 8, remember, for b. So if we go back here, like for any of these, so the base cannot be negative, remember, so x cannot be negative. So therefore, this is extraneous. This is extraneous. So our real solution is 27. X equals 27. Okay.